All right, welcome back. So we're going to pick right back up where we left off. So currently we just have basic connectivity between PC1 and Switch 1, nothing more than a VLAN and a default gateway. So we can still see, you can see those pings I just left off on are there, and the switch has the interface up and up, which is good. So we're going to go over to Switch 2 now. All right, and then we're going to go to PC2 as well. So on Switch 2, first things first, we'll give it a quick host name to match the topology. So host name is A Switch 2. We'll go ahead and this time around we're going to create, I'll show you a different way to get the VLAN created. So a lot of times you'll be in a rush and you'll forget to define the VLAN and you'll go into the interface first. So in this particular case, E00 is the one facing the computer. So we're going to go into interface E00 and we'll give it a quick description. We'll say link to a PC2 and we're going to say switch port mode access, and we're going to say switch port access VLAN 200. So we're going to extend that VLAN 200 between the switches so that this PC should be able to ping this PC. Okay? So watch what happens here. In this case, I did not create the VLAN first. So let's go ahead and hit enter. And it says the access VLAN does not exist, and it says I'm going to go ahead and create that for you. Well, thank you, iOS. That's very nice of you. So if I look at show VLAN brief, I can now see that I've got a VLAN 200. Sorry about the no VLAN 10, no VLAN 11. That was a remnant. So do show VLAN brief. Okay. So now we've got 200, and we can see that in this case it's already in 00 because we put it there, right? The only thing we don't have is a nice name, right? So order of operations, all we're going to do here is go into VLAN 200 and we're going to say name VLAN 200, show VLAN brief. So now we can see that it has the same VLAN name as the one on the other switch. So good news there. So now that gives us the connectivity between Switch 2 and PC2. However, we've got to get this link between the switches configured so that this PC can ping its default gateway, which is actually on Switch 1. So before we do that, let's just get the IP address on PC2. So if we show IP, we can see that it doesn't have one right now. So I know we said we'd make the PCs .10, but since he's on the same VLAN, we'll have to make him the next available. So we'll say IP 10.1.1. We'll make him. Actually, let me change this just because it's going to be easier for me to remember. So let's make him 12/24. His gateway is 10.1.1.1. Okay, so it's going to check for duplicate. It's not going to find one. Let's just change this PC to 10.1.1.11. That way it's just easy for me to remember. Alright, so we've changed that. And he's officially configured. So if we show IP, he's got .12 with a gateway of 1. So let's talk about the switch-to-switch connectivity. So switch 1, they're connected together via E03. So let's look at E03. And we can see that it's got a whole lot of nothing on it. Show run interface E03. So neither switch has any configuration, which is fine. So it's going to be very similar to what we did for the connectivity down to the PC level. We're going to define the mode of the switch port. And I had hinted at the trunk with the question mark command last time. That's actually where we're going with this. So interface E03. So we can give it a description. We'll say it's going to be the trunk to a switch 2. All right. We're going to say switch port mode, but instead of using access, okay, we're going to say it's a trunk. So as you will learn, trunks allow you to pass more than one VLAN over that interface, as opposed to the access port is only allowing the specific VLAN that you tell it to. So we're going to say switch port mode trunk. All right. Oops, sorry, old version of code. We've got to tell it that the encapsulation is going to be .1Q or trunk or what it needs. So we're going to say switch port, trunk, encapsulation, and we're going to say .1Q. Now if I hit the command switch port mode trunk, it should work, which is fine. On newer flavors of code, you don't necessarily need to deal with that, but this is an old version. So switch port mode trunk, encapsulation is .1Q, and we gave it a description. So if we look at it one more time, that's what it looks like. Let's just verify that it's up. It is, so that's a good sign. So let's go ahead and do the same exact thing on switch 2. Switch port trunk encapsulation .1Q, switch port mode trunk. Description is going to be, I said trunk to a switch 1, and what we should see now is it's connected. It is a trunk, which is good. And let's just do another command, show CDP neighbors. So we can see that based on Cisco Discovery Protocol, we've got a neighbor of switch 1 out of our E03 interface, which is awesome. So that is a good sign. So the other verification is show interface trunk. So if we show interface trunk, it tells us that 03 has trunking on. It tells us it's using .1Q encapsulation, and its native VLAN is 1. We haven't talked about native VLANs, but for this particular example, it's irrelevant. It is allowing 200, which is good because that is what our PCs are sitting on. So this is looking very promising. So if we go to switch 1 and we do show interface trunk, we can see it's on .1Q, trunking, and it should be passing VLAN 200. So what we want to try to do now is let's take a baby step. We'll go to PC2. Let's go ahead and try to ping its default gateway. Look at that. So now PC2 is pinging its default gateway, which it's going to switch 2 across the trunk to get to that gateway. So it's actually pinging its gateway, which is, 2 hops away, if you will. So we know that PC1 can ping its gateway, but let's just do it one more time for sanity's sake. If I can type. Alright, so we see that it's perfectly happy. So let's go ahead and go for the glory. So let's see if PC2 can ping 10, 1, 1, 11, which should be PC1. And it can. That is a good sign. So we see that it's 1, 2, arguably 2, 3 hops away. If we do a trace route, it is indicative of being directly connected. So that goes back to what you're learning about with broadcast domains, collision domains, all that good stuff. So since it's a layer 2 segment, even though it's more than one switch away, it thinks it's on the same, it's virtually on the same network segment or the same broadcast domain, so there's no hops in between. Even though it's going through various hardware devices, it is, for all intents and purposes, it looks as if it were directly connected. Okay, so we're going to stop there. The next video, what we'll do is we'll change this to be VLAN 300 instead of 200, just to make sure that we've got inter-VLAN connectivity going on, and we'll continue to progress from there.